So this week we're going to talk about map scale, ways that you express scale, what scale is, how to convert from one type of scale to another scale, and we'll practice doing that on some maps. So a scale is just the amount of reduction from the real world. So if I wanted a map the size of the classroom, or if I wanted a map that with no reduction, it would have to be the size of the classroom. So if I have a map that's a 1:2 scale, it would mean it's half the size of the classroom. So we can talk about maps scale in several ways. One is the representative fraction, or the RF. The other is a graphic scale. We use a word scale. You'll see that a lot on some of the state road maps. They'll say 1 inch equals 50 miles or something. And then there's this generic term, large scale versus small scale. So let's start with the word statement, 1 inch equals 100 miles, or 100 miles equals 1 inch. And often this is somewhat rounded. If you tried to convert this if you used a representative fraction and converted down to 1 inch equals 100 miles, it'd probably not be completely accurate. But you wouldn't want to say, 1 inch equals 1,032 miles, because who would ever measure that narrow on just a regular map? So the representative fraction is also called the ratio scale, and a representative fraction has no units. Okay, so 1 to 100, there are no units implied in this map. If you like to measure in centimeters, what it's saying is 1 centimeter on the map is the same as 100 centimeters on the ground. 1 inch on the map is 100 inches on the ground. It is completely unitless. It would be incorrect to write this 1 to 100. So why it is probably mathematically correct, it's not mapping convention, so you would lose points for that. And then there is large scale versus small scale. So when we're talking about large scale versus small scale, we're really referring back to the representative fraction. And a large scale map is a map that has not been scaled down very much. There is less land showing, but the objects on the map are big. And so the RF is actually a larger number than the RF on a small scale map. So if you think about this again as a fraction, 1/20th is actually a bigger piece than 1/50 millionth. Okay? So you have to, when you look at small scale and large scale maps, you really need to kind of think about, even though this number on the right side is larger, the fraction itself is a smaller number. So a small scale map, the elements have been reduced. The land you're looking at probably a larger piece of land, but the features are very small on that. So here's an example. And so this is a map that's showing 1 to 20,000. You can see roads, I can see some school symbols, I can see street blocks, and here is a zoomed out map of 1 to 50 million, and I can see maybe major rivers and streams and some points for a city location. But here is that same town next up. If anybody knows how to say that, that would be great. So you can see that this is a large scale map, this is a small scale map. The graphic scale, or the scale bar, I don't even have a cool picture of a graphic scale or a scale bar. Hold on a second, let's just go find one of those. Alright, let's go to graphic scale. Right, let's see what we've got here. Oh, there they are. Look at that. Graphic scales. Actually, this is pretty cool because now we're going to get into all kinds of messy stuff here. Here's a nice image for a graphic scale, or not. Okay, so it's just a bar graph. typically it'll show increments in feet or miles or meters, kilometers. The nice thing about a graphic scale is it can have bars, 3 or 4 different bars that show all the different options. You can measure in miles, you can measure in kilometers, you can measure in feet. If I have my map and my graphic scale and I enlarge that, it will enlarge or reduce with the map. A lot of people like them because you can just visually get a sense. They're easy to use and to find distance on the map. The ratio scale, that's a little more difficult. It doesn't mean that much to me. If I were, I don't know what 1 to 40,000 is, I would want to see that in the graphic scale. So they're very helpful. Okay, where am I here? When we talk about large scale versus small scale, it's somewhat on a continuum because they can be relative to each other. I might say, somebody says, make me a small scale map of the United States. So again, you're going to think about the whole US on a sheet of paper, and it's not going to be a huge sheet of paper. But when you look at them in kind of types of maps, you've got kind of the largest scale would be an engineering plan. So not a lot of reduction. 1 foot equals 1,200 feet. Or in a word scale, this would be 1 to 100. Yeah, 1 inch to 100. Aha, I thought that. And then you can go all the way down to a world map, which is the smallest scale. So topographic maps kind of are in that realm. They can merge from a large scale to a medium scale map. So I want you to be able to convert, because sometimes, like as I said, a ratio scale isn't that helpful to really use it to measure things. So so you need to first, if you're converting from a word scale to an RF, the first thing you need to do is to make all of your units the same. And so you need to know 1 foot equals 12 inches, and 1 mile equals 5,200 feet. And also, some people may not remember that there are 3 feet in a yard. That would be helpful to put in here. For those of you who work in meters and not the US system, there you go. So that's kind of the common units. It's really nice to memorize this. 1 mile equals 63,360 inches. So to convert a word scale to a RF scale, you're going to set up an equality. So I have 1 inch equals 4 miles. So I'm going to put my 1 inch over the 4 miles, and then I'm going to set up a series of multiplication problems where I can cross out units. So 1 foot equals 12 inches is the same thing, right? So I'm not really changing the values anyway, because I'm still making an equality here. 1 mile equals 5,280 feet. Again, that reduces down to 1, so I'm not changing anything with my math. I'm just changing the units. So I can cross out inches and inches, I can cross out feet and feet, I can cross out miles and miles, and then when I multiply straight across, I get my RF, which is 1 to 253,440. 440, don't say the and. Okay, so that's the way to convert to a word scale. To convert to a RF scale from a word scale. To convert to a word scale from an RF, you're going to kind of work it backwards. Now, instead of getting rid of the units, you want to keep the miles at the end of the equation. So, because you're going to kind of reverse that setup. So I'm going to say 24,000 inches, right? Because I can make that inches over 1. So I haven't changed that value any. Is the times 1 foot over 12 inches times 1 mile over 5,280 feet. So what I'm going to get rid of are all of the inches, I'm going to get rid of these inches and these feet, and I'm left with miles. And what I'm saying here is 1 inch equals 24,000 inches. So now 1 inch equals 0.38 miles. Okay, and if you put 0.4 miles, that would be fine too. That would be pretty close if you round it off like that. Okay. Sometimes when you make a map, it's important to know what map scale to use, and it gives you a sense of how to kind of set up your project. So if I wanted to make a map of Arizona and I want to use a piece of paper, 8.5 by 11 inch piece of paper, and I want 1/2 margins, my finished paper size is going to be 7 by 10. So I have to decide which orientation Arizona is going to be. Is it longer north-south or is it wider east-west? So it looks like Arizona is longer north-south. So I'm going to put that on the 10-inch side, right? So I'm going to turn my paper into portrait orientation so I can fit that north-south area there. So the north-south is equal to 10 inches times that many miles, and the east-west is equal to 7.5 inches in that many miles. So let's see how you actually calculate that. So I know how many inches in a mile, right? So I actually want to just say how many inches is 395 miles. So I multiply that and I get this many inches, right? Now I want to reduce that to fit on 10 inches of paper. So I'm going to divide that by 10 inches and I'm going to get my representative fraction, or my ratio, of 1 to 2,502,720. Okay? For the east-west extent, I have to do the same thing. So how many inches is 340 miles? So I multiply that, I divide that by my allowable space, and I get my reduction of 1 to 2,872,320. Then I need to look at both of those and decide which scale I need to use, right? So when I look at these two scales, I have to choose the number that is the smallest. If I choose this number, let's see, there we go. Yeah, if I choose this number, the east-west extent is not going to fit on my map. Okay, so you can't just decide that this is the map is longest. A lot of people, what did they do? They looked at this and they said, oh, okay, so this is my longest extent. I'm going to put that on the 10-inch piece of paper, and they didn't figure out what the east-west is, because sometimes that doesn't work out. So you need to do both, and then you need to pick the smaller number to be your amount of reduction.